Hello students. So my name is Devrib Ghosh. Today we are going to discuss the mock 49th paper that was on the date of 10th January 2026. So our course of solving this question will be exactly the same as we used to do. The only difference is that from the last video when I made, I pre-sorted all the tough and easy ones. However, in this paper, I will try to sort them out as we solve the question. Okay, so let's proceed without talking any further. So this is the first question. Let me choose a proper color. So a circular current loop of magnetic moment capital M is in an arbitrary orientation in an external magnetic field B. Okay, now they are saying the work done to rotate the loop by 30° about an axis perpendicular to its plane is. Now perpendicular to its plane means, let's try to understand how to solve it. So let's say we got an axis like this is the loop. Okay, now they have given the magnetic field to be at any arbitrary angle. So let me assume any arbitrary angle like this. Okay, oh, that will become perpendicular, right? I mean, I don't think so. Fine, let it be like this, right? Now if I look at the axis, what they're talking about, they're saying an axis which is perpendicular to the plane. Perpendicular to the plane means this axis. So about the axis, if this thing rotates, so the rotation will be kind of like this, rotation like this. Now if you look at it, the area vector is not doing any kind of rotation with the magnetic field, and in that scenario there is no work done between that in this scenario, so work done is 0. Next question, let's see what does it say. A plate of mass 10 gram, so this is small m, is in equilibrium in air due to the force exerted by the light beam on the plate. Calculate the power of the beam. Okay, assume the plate is perfectly absorbing. If the plate is perfectly absorbing, you know P by C, not 2P, just P by C, that can give you power. Let's calculate. If you forget that formula, you can check dimensionally as well, but this thing will give you the force mg. Okay, see, if we want to verify, power P is energy by time, so I can write energy by time, and this thing is distance by time. Now time will cancel out, I get energy by length, and that is the same dimension as force. So just remove all these stuffs and try to solve it. So let's put the value. M they have said is 10 grams, so 10 into 10 to the power minus 3, G is 10, power P over C is 3 into 10 to the power 8. So if I multiply, I get 3 into 10 to the power 8, 9, 10 minus 3 is 7. That is the power P. So option B is the correct one. Okay, a bullet is fired from a gun. The force on the bullet is given as this thing, where F is in newtons and T is in seconds. So all SI. The force on the bullets becomes 0. So force becomes 0 as soon as it leaves the barrel. So if I think of it physically, let me show you. So say this is the barrel, okay? Okay, let me, this is the mechanism of the gun. Like there is a trigger and everything here, okay, right? The very moment there is gunpowder blast, say this is the bullet, there's a gunpowder blast and the bullet is going and coming here. The very moment it leaves the barrel, the force becomes 0. All nice. What is the average impulse imparted by the bullet? You see, impulse is nothing but change in momentum, right? So basically, if I can do f dt and integrate that, I will find out the impulse. Now you see, time, the limit, that is important to us. And how to get that? That information is supplied by here. They say the force becomes 0 exactly when it leaves the barrel. So if I just make the force F equal to 0, since it is also a function of time, I will get the time when the force becomes 0. Basically, that means I will get the time when the bullet leaves the barrel, right? Just put it equal to 0. So F equal to 0, that means time t will be 600 over 2 into 10 to the power 5. So I get how much? 3 into 10 to the power minus 3. Okay, so this is the amount of time, second. Okay, let me put the unit, this much second. Right? Yeah, I hope my calculation is correct. Let's come back here. So f dt, I'm not going to solve the integration in a very huge detail, but let's go there. 600 is a constant, right? So if I integrate that, I will get just 600t with the limits, correct? Minus, second term is 2 into 10 to the power 5t. I hope all of you can do that. So constant part 2 into 10 to the 5 come out, and then for t dt will be t square by 2 with the limits. Now what is the limit? Let's say this time is t, or rather some specific tau. Let's say it's tau, it's a special time. So time limit will be 0 to tau, this thing will be 0 to tau. Let's put the limit very quickly. So 600 into t is 3 into 10 to the minus 3 minus this 2 and this 2 I can cancel out actually. This 2 can be cancelled out with this 2, and let's see what do I get. So t square, huh? So I get 9 into 10 to the power minus 6 plus 5. So 0.9, and here I get 18 into 10 to the power 3, that means 1.8. 1.8 minus 0.9, that is 0.9. And since all the things are SI, answer will be SI. Option C is the correct one. Let's go to the next one. They have said a particle which is constrained to move along the x-axis is subjected to a force in the same direction which varies with the distance x of the particle. Fx is given like this: minus kx plus ax cube, where k and a, these two are positive constants, right? Very much ideal scenario. Now they are saying for x equal to x greater than 0, function of the potential energy from the particle is very easy question. You all know potential energy U is nothing but negative integration of f dot dx. I mean, there's a vectorical sense. Here there is no sense in vector, but everything is linear, the scalar form. Just scalar integrate that stuff. So they get minus, and okay, this minus and this minus will become plus. So kx square by 2 with a plus, and then here's a plus, and this minus will make the second term negative. So negative a x4 by 4. Here I did just a subtle step jump. X's cube integration is x4 by 4. That's it. I hope all of you understand that much. Now let's try to see how will this plot look like. Now, as you all have the basic knowledge of mathematics, you must know that when x is smaller number, this term with the smaller power of x will dominate. This part will dominate when x is small. And if that part dominates, what will happen you all know. If I just try to make the random graph by my hand, that is a plus kx square by 2. So that is something like parabolic up, something like this. Now let's go to the next part. So this is when x is small, so small region of x. What will happen if x increases further? So this term will dominate. This term will dominate when x is large, correct? If x is large, the second term, which has got the higher power, that will dominate. Now if you look at the second power, it has got a negative in it, so it will try to reduce the value of the function. So if I reduce it like that, so it will go somewhat like this. Now let's try to look at the options, and you all probably will agree with me that this one looks the closest to what we have tried to draw with our hands. So option D is the correct option. Let's go to the next one. A sphere of mass small m moving with velocity, with a velocity. Acha, how much velocity they have not said. Hits another stationary sphere B of the same mass. Nice, mass is the same. If the ratio of the velocities of the sphere after collision is VA by VB equal to 1 minus A by 1 minus E by 1 plus E, where E is the coefficient of restitution, you all know. What is the initial velocity of the sphere A with which it strikes? So let us try to recreate the scenario. So we see that, say this thing was going with some U and this thing was at rest. Now what happened after the collision? This thing moves with some VA and this thing moves with some VB. Correct. Now they're asking us to find out this U. That is the question mark. Let's try to decode that. So how would we define in this scenario? I would just say coefficient of restitution is velocity of separation by velocity of approach, and velocity of separation is Vb minus Va, and velocity of approach is u, because the other one is stationary. Now let's see, can I find anything in that form or not? Let's try. So I got Va over Vb is equals to 1 minus E by 1 plus E. Now we will try to do, I will try to come in that format. Now you see there is only E, but I have got some 1 plus E, 1 minus E stuff. So I would try to do something like a componendo dividendo. So what's my idea here? I want just to have E, right? Just to have E, I will add denominator with numerator. So 1 plus E, no, I will subtract them, denominator minus numerator. So 1 plus E minus 1 plus E, right? Yeah. So this thing will be Vb minus Va, right? Now denominator, I will do the opposite thing. I will just add them up. So 1 plus E plus 1 minus E. Same story here, Vb plus Va. Now let's see what do we comprehend from here. So 1 cancel out, E cancel out. I got basically 2E by 2. So basically E, you all understand. So I believe now it has matched the same format as we try to predict. The left hand side is here, and the numerator Vb minus Va is this V minus Va. Numerator, this thing is supposed to be the U. Got this? Let's see. So Vb plus Va, option A here is the correct one. Let's proceed. If the focal length of an objective and eye lens are this, so this thing is FO and this thing is Fe. Obviously this is also in centimeter, and the object is put 1.2 centimeter away from the objective lens. Which one? Objective. So I will say this is UO. And the final image formed at infinity. Fine. The magnifying power of the microscope is. Now I believe many of you remember the formula, and if you do, it is very nice. But for those who have forgotten, I will try to quickly make a sketch to derive the formula. So this is the objective, this is the eyepiece. Oh, this is the, yeah, correct, right? This is the object, this eyepiece. Then what happens? Here is the object at a distance of UO. Then there will be one light passing through this, one line passing like this, and this will be the point where there will be one image created. This one height I will say h dash, this height is h. Then again light from this point will go, one will go through the center, optical center people say, another will go like this to go like this. Both are parallel, so I will backtrace them, they will go to parallel. So basically infinity, I think that's what said, final image is formed at infinity. Now, so from this scenario, what I would derive here is that I would say this angle is alpha, or rather, yep, let's call it beta. So this angle is beta, okay? Now, the other one is the object. So this is the visual angle. This thing is called beta, is the angle, visual angle for the final image. Now for the object, if I see, the formalism is that you keep the object at distance d, somewhat like this. Now try to find out the angle, right? So, yep, this distance here at the base will be capital D, and this is the original object, so height is h, correct? And this angle they say is alpha. Now, how do you define the magnifying power? You see, magnifying power m is beta over alpha, correct? Beta over alpha. Now, what is beta? You see, beta or similarly tan beta is nothing but h dash over the object distance from the eyepiece. But I know object distance here from the eyepiece, UE, is same as FE. Obviously, if you put the object as at focus, then only the final image will be at infinity, right? So UE equals to FE. So I can directly write beta here comes out to be h dash over fe, and alpha, where is alpha? This angle is alpha, which is h by d. So what do we get here? Beta by alpha. So h dash by fe and h by d. So I get h dash over h and then d by fe, right? You see, this h dash is the image height created by the objective lens. Which one? Objective lens, the focal length. So basically objective length. So I need to find out h dash by h, and you all know this is nothing but the magnification, linear magnification of the objective lens. And so I can write the formula 1 by v minus 1 by u. So all are for objective, 1 by fo. Now if I put 1 by vo is equals to, this thing will become uo plus fo. And be very cautious here, I have not put the sign convention. So if I look at this h dash by h, so VO by UO, that is the magnification by the objective lens, that is same as h dash by h will be same as, from here if I do V by U, so I get FO by FO plus UO, right? You can do it by your own hand to verify the calculation, otherwise you won't understand. Try to write this calculation by your own hands. Now if I do the same thing here also, so what do I get? This is the magnification factor M, okay? So M will be h dash by h, so basically this thing I am going to use FO by FO plus UO and D by FE. FO by FO plus UO and D by FE. Now let me quickly take the values from there. Oh, by the way, as I'm again telling you, I have not used the sign convention, that's why I have to now. So FO is 1.2, FE is 3, 1.2, 1.2, D is, everybody knows, 25, this is 3, and then UO. UO is how much? UO is 1.25, but be very cautious, U is the object distance, always comes to be negative, so minus 1.25. So I get 1.2 into 25 by 0.05 into 3. Let's proceed further with this calculation. So what do we get? If I cancel this out, it becomes 0.4. 0.4 into 25, 10, right? 10 by 0.05. So if I take this point, I will get 2 zeros here, and then it will give me 200. And there is a minus sign. This can be taken. Otherwise, our question doesn't have any minus sign. I will just pick the answer, 200. Now let's proceed to the next one. So let's see what does it say. In the figure, an arrangement of Young double slit experiment is shown in the okay. A parallel beam of light of wavelength lambda in medium N1. So lambda is in medium, is incident at an angle theta as shown in the figure. S1O equal to S2O. Okay. So this is S1O, this is S2O, just for the reference. Okay. Okay. Point O is at the origin of the coordinate system. Yeah, indeed, it is the middle of the screen, as we say. The medium of the left and right side of the plane have refractive index N1 and N2. As you all can see, the left side is N1, the right side is N2. Next, the slit have, now the distance between the slits is D. Okay, this distance, as I say, is small d. Nice and fine. Distance between the screen and the plate is capital D. Okay, this is capital D. Okay, next, they have given the values here. Now, what is the final question? The y coordinate of the point where the total phase difference between the interfering wave is 0. Okay, so they are asking us to find out a point where the, what is it, 0? Where the phase difference between the wave is 0. Now, look at it very carefully. As you all have done this in this angle incidence, this is a little tough question. So actually we can do this at the last, but still, since we are going in the same pace, so I am describing this question for you. So if I drop a perpendicular here, so you see this is the wave front. So basically this point, these 3 points, let me put it different color. So these 3 points are in the same phase. That basically means the lower light has traveled more length now, right? Now the lower light has traveled more length. That is what will make the lower light to get ahead by some phase. This one is lagging by some phase. Now let's try track out some point on the screen where the phase difference is 0. You see guys, now if I look at this other point, I mean after this S1, S2, if I look at this line and this line, now they are traveling the same distance, right? But the lower one, this ray has already traveled more distance. So I have to decrease the length of the path traveled by the lower ray. Then only their phase will become compensated with each other, right? So now think of it physically. I need to lower the lower hand. I need to make it little. So what will happen? The thing will become going down. So obviously that point which we are hunting for will lie a little down here. Now let us quickly find out that point. How to do that? So here if we see, this is the path difference delta x, and delta x can be given as d sine theta, right? Small d sine theta here, this one. Now you see what happens, the light when they go in the opposite this direction, when they go, this is the point y where they make the phase difference 0. But the problem here guys, we do not know this point y, this displacement y, is it a small number or is it a big number? Until and unless we know that value, we cannot apply that formula directly. The n lambda d by d, or basically phase delta x equals to delta x into, this is a very famous formula, delta x into capital D by small d is equals to y. This formula cannot be applied here, because if you followed the derivation of this formula, if you followed the NCRT, there is an approximation that this y also must be very small. But in this question, the y cannot be said to be small because we do not have any prior information. So let's say that phenomena happens at some angle phi, at certain angle phi. So what can I say from here? I can directly say tan phi will be y by capital D, correct? Tan phi is y by capital D. Now, so I need to find out that phi somehow. Let's see how to do that. And the path distance, how much path this traveled by here. Say here the light is coming from top and here the light is coming from bottom. So how much will be the path difference in this case also? Here also if I draw this perpendicular, you guys try to see this angle is phi. On this line this is perpendicular. On this line this is perpendicular, this one. So I can say this is the path difference. This will be d tan phi. D tan phi will be the path difference. But okay, when you are talking about the path difference, we should also employ the medium here. You see, here the medium are different, N1 and N2. It is not air, right? So when you are writing the expression of path difference, you should also employ the optical path length. So delta x equals to d sine theta equal to mu1, and here the delta x dash will be d sine phi into mu2. Here they might have said n1, n2, na? Okay, let me put the proper formalism. Since they have already used n, I will use that. n1, n2. So I hope you understand. This is the optical path length difference. Optical path length difference in the first medium. This is the optical path length difference in the second medium. Now this is in one direction, lower one travels more, and by this thing the upper one travels more. So this portion is kind of a correction. Now they have to be same with each other. So let's see if we equate them, what do we get? So d sine theta n1 equals to d sine phi n2. Let me put the value really quick, but before that I will swiftly cancel out the d. Now sine theta, they have given how much theta? 30, huh? So half n1 must be given 4 by 3, sine phi n2 must be given 10 by 9. Let us again do the calculation here. Let's see. So 4 becomes 2, can be cancelled out with 5 here, 3 can be cancelled out with 3. So I get sine phi, let's do the crisscross, 3 by 5. That's a very known one, the magic ratio. So sine, magic number or magic ratio people say. So sine phi equal to 3 by 5. So angle theta equal, sorry, angle phi equal to 37 degree, right? So angle phi 37, I can write tan phi, that will become 3 by 4. So y by capital D. So 3 by 4, capital D is how much? Let's see, 1 meter. So 1, that is y, that is 3 by 4. So 3 by 4 is the correct answer. And as I just convinced you logically that for the lower ray which has already traveled more distance now has to travel lesser distance. So the point on the screen has to be lower than the geometrical center. So minus 3 by 4 is the correct one. So let's see, do I have the options with me? I think I do not have. So option would be minus 3 by 4. Answer will be minus 3 by 4 meter, right? Meter. Okay, let's go to the next one. The capacitor shown in the figure is in steady state. The energy stored in the capacitor is. Let's see how to find out the energy stored in the capacitor. Since it is in steady state, everybody knows that no current is flowing through the capacitor, right? Now you know voltage here will be, say, okay, I don't need to do that. Simple story is here the current I is flowing. Since these two are in parallel, they are same resistance as well. So symmetrically current I will also flow through this. Since through the capacitor no current is flowing, the current will already go with the whole current will go past through the R resistance. So voltage here, voltage against the capacitor will be same as the voltage across the resistance, that is equals to 2IR. Now energy of the capacitor will be half CV square. So half C into 4I square R square. So 4 and 2 will cancel out, 2 Ci square R square is the correct one. Let's go to the next question quickly. The total heat produced in resistance R in an RL circuit when the current in the inductor decreases from I0 to 0 is. So when the current is I0 in the circuit, what happens? The inductor has got some energy, half L I0 square. When this current now discharges through the resistance, the only way this energy can dissipate is through the resistance, because you all know that inductor does not waste any energy. So simply I can say the energy will be half L I0 square. However, if you are very keen to calculate that, you all know energy discharge, when the inductor discharges, current equation can be written as I0 e to the power minus t over tau, right? Now power through the resistance, power dissipated through the resistance can be written as I square R. If I proceed with that, I0 square e to the power minus t by tau, that is the power expression. Now to find out the heat dissipated, I will have to integrate that stuff, right? Okay, so did I forget to put a 2? Yeah, there is a 2. Now I0 square, so e to the power minus 2t over tau and dt here, integration from 0 to infinity, because you know theoretically inductor or capacitor takes infinite amount to completely discharge. Now I need to integrate that. So to manipulate this dt, I will put 2. So tau by 2 I need to put. So I0 square tau over 2. I hope you understand this math. So it will come out to be e to the power minus 2t by tau with the limit 0 to infinity. Right? Now if I put the limit here, how much will I get? Some negative will come. But I am not talking about the negative 1 or plus 1, whatever it comes. Yeah, I am only now, okay, no, negative will not come actually, right? Because in the integration itself, there should come a negative. And this negative and that negative one from here can compensate. And anyway, I'll get I0 square tau by 2. Am I correct? I didn't miss the resistance R, right? Sorry, resistance R was there, resistance R was there, resistance R was there. So yeah. Now, you know tau, just put the expression for tau. So I0 square by 2 here, resistance R, which was there, Okay, I cannot write 2 somehow. Okay, let me do it on the other side of the board. So I got H equals to I naught square R by 2, tau is L by R. So, yep, we got this R cancel out, half I naught square into L, half L I square, simple story. Same formula, same thing. We can do this logically as well. Instead of wasting any time like this, I would seriously suggest you, for any physical problem like this, if you know the theory, if you understand that, if you reason with that, just put it directly. Why to bother? The pressure versus temperature graph of ideal gas as shown in the figure. The density of the gas at point A is rho naught, density at B will be. So here the density they have said is rho naught. Okay, let's see. Mass of the gas is not changing. We have to assume that for sure. Now let's find out what is the volume at this point, right? You know, PV is equals to nRT. So at the point A we are talking about, right? So I can write volume V equal to nR, that's a constant obviously. So T naught over P naught, right? Now you see this volume of A. Similar story, I can write volume at B, nR is constant, the same mole number because mass is not changing as I said. At this point B can be written as temperature is 2T naught and pressure is how much? 3P naught. Done. Now you see density ratio rho A by rho B, right? No, rho B by rho A. That is same as some rho B by rho naught, because rho A they have said rho naught. You know, density is the inverse ratio of volume, right? So VA by VB I can write. VA by VB, if I do, I will get T naught, P naught, NR, they will cancel out. So 1 by 2 by 3, basically 3 by 2, right? Am I correct here? Okay. So what do we get? Rho B is equals to 3 by 2 rho naught. I hope most of you already got it. This is the correct one. Okay. Okay. Let me mark it properly. Yeah. 3 by 2 rho naught. Let's go to the next one. Pretty simple question actually. Let's look at this one. A U-tube of uniform cross section shown in the figure is partially filled with liquid 1, liquid 1. Another liquid 2 which does not mix with 1 is poured into one side. So this is the one which used to be there. Now there is another liquid number 2 is put from there. The liquid level of the two sides is found to be the same. Find the liquid level is same. While the level of liquid 1 has risen up by 2 centimeter, the specific gravity of liquid 1 is 1.1. The specific gravity of the liquid 2 must be. Here you look, if you know the theory, if you have carefully studied the system, you must know that when the densities are different, there must be some height difference, isn't it? Here there is no height difference. So without solving it, directly I can say that their density is same. That's this easy. But nonetheless, even though my task here to solve the question only, but I will still give you some glimpse of the concept. Here, if there were some difference in height, say if this is x extra, here the density is rho 1, here the density is rho 1, this density is rho 2. How to solve this type of system is that draw a line from here. Okay, now you see, if I say this height is h, this height is also h, but this one is x extra, right? Now you write the expression for that. Key rho, here the mass would be same as the mass, or basically the pressure at this point, same as pressure at this point. So weight of the upper column, which is density rho 2, area A, anyway will cancel out, then h plus x. I would just show you. So rho 2 into h plus x, every other stuff will cancel out, will be rho 1 into h. That would have been the way to solve this. But nonetheless, in our case, x is equals to 0 because they are the same height. There's no difference in height from the top end. So, yep, the same answer, okay? Just for the educational purpose, I wrote it. Let me remove this stuff because it's not anyway relevant for our problem. Let's go to the next one. So what is the energy required to launch a mkg satellite from the Earth's surface in a circular orbit at an altitude of 2r. At an altitude of 2r, that means small r, that is the distance from the center of Earth, will basically become r plus 2r, that is 3r. Now, how to solve this question? The work done or the energy provided is basically the subtraction of the energies. So, energy final minus, okay, I am writing here total energy initial, final minus total energy initial, that is the amount of energy that is provided, right? What is the final total energy? If it is at 3r distance from the center to center, so I just know G mm by 3r with a negative sign. Then this thing is minus initial energy, since it is on the surface of Earth. Oh, I forgot to put up half here, because you know half here. Why? Because total energy is half of the potential energy. Now when the object is on the surface of Earth, you know they haven't mentioned the body is moving anyway, so kinetic energy is not there, only the potential energy on the surface of Earth. So just put the expression for that, minus G mm over r. Now if I do that, what do I see? So G mm over r minus 1 by 6 G, okay, G mm over r, so I get 5 by 6 G mm over r. Now we can convert in this form, mgr form, you all know, because gm by r square is the small g, so I get 5 by 6 mgr. Anyway, this numerical factor is the only important stuff here, right? Okay, let's go to the next one. A and B are two adiabatic curves for two different gases. Then A and B corresponds to. Now here we all have the information that the one with higher gamma will have more, what is it called? It is more, what is it? Slant? Or maybe, you understand that, right? That will be more tilted, or will be very more sharply tilted. Okay, let's go with that. So simple story, B has more gamma. B has more gamma. And you all know the expression for gamma, 1 plus 2 over F. That means more gamma signifies lesser degree of freedom. Lesser degree of freedom. Now let's look at it. So we all know monatomic has the least degree of freedom, diatomic has more, then comes triatomic, triangular. So I can say so this one has lower degree of freedom, right? That means B is monatomic. Monatomic. So diatomic, monatomic. This is the combination. Got this? Next one. The average translational kinetic energy of O2 molecule at a particular temperature is this much. Okay, a single molecule we are talking about, aren't we? Oh, that also only about the translational kinetic energy. Interesting. The average translational kinetic energy of nitrogen molecule, oh, that's a pretty simple question. Those who fell for this trick and started calculating it by wasting their time, that's a huge blunder, I would say. Just it comes from the equipartition of energy. Equipartition of energy says energy per unit degree of freedom per unit particle, per single particle is half kT. Per particle per degree of freedom, energy is half kT. Kinetic energy is half kT. Now, if they say about translation, only 3. Any molecule, if you talk about monatomic, diatomic, triatomic, any configuration, if you say, translation is always 3. So that energy is always the same. So 0.048. Next. A car has to cover distance 60 centimeter if half of the total time traveled with speed 80 kilometer and 80 kilometer per hour, and half time its speed E is 40 kilometer per hour, the average speed of the car. So that's a pretty simple question, and this thing is pure gimmick. Just to check whether you get confused or not, you all know if the time interval is same. So I can write average speed to be v1. Okay, total distance, let me draw it. That will become better for you. So I need to go from here to here. Say first is 80, right? So we'll travel more. So this is distance S1, this is distance S2. This takes time t, this takes time t, same, right? So I will just write average speed is equals to S1 plus S2 over total time, which is 2t, right? That is equals to this distance S1 is nothing but V1t, other one is V2t divided by the total time, which is 2t, right? Now if I do that, t will be cancelled out, so I will get V1 plus V2 over 2. Simple stuff. So I get 80 plus 40 by 2. That is 60. This is the correct answer. Let's proceed to the next one. So as far as I have gone through this paper, I mean, like as we are doing it, the questions are pretty much simple. Only one question of that YDAC had a little trick. Other than that, all are pretty much flat, I would say. A rod closing in the circuit shown in the figure moves along U-shaped wire at a constant speed V. Okay, constant speed V. So we'll have to apply some constant force also externally, right? Indeed. The circuit is in a uniform magnetic field perpendicular to the plane. Calculate F if the rate of heat generation in the circuit is Q. Rate of heat means basically they are talking about the power. So, okay, rate of heat generation is Q. So, how to write that? Q, that is equals to, you can do this directly here also, but still I would try to do it with very basics. So this is nothing but I square R, right? Now I need to know the expression for I, and I is what? Nothing but EMF by resistance, right? And EMF is what? BLV, right? By resistance R. So I will just come here, B square L square V square, and this R square, and there will be an R. So there will be a cancellation of the power. B square L square V square over R, right? Now let's talk about the other quantity which is in the expressions, which is force. See, force F on a current carrying conductor, since the current, if there is, will flow through this loop, this force is nothing but B I L, right? And B I expression we already got, BLV by R, BLV over R, and there is L, so I get B square L square V over R. And here from these two different, the only difference is that there is an extra V, so I can write this thing as F into V. Now you can manipulate this thing, so force will be Q by V. Force will be Q by V. That's what. Here also, if you apply the simple logic, here the power will be dissipated through the resistance here, and the same power, whatever power is dissipated here, let me apply the logic and solve this in a single second. I mean, not single second, that will be too much exaggeration, but anyway, you look, whatever force I'm applying, that force is giving some power. Some power I'm giving here, power input. Now look, it is moving with the same speed. So there is no, magnetism does not have any potential energy involved. Kinetic energy is constant. Why? Because it is moving with the same speed. That means whatever rate I am giving the power, at the same rate power is dissipated. So I can straight away write Q is the dissipated, will be same as the power. I would write with Q, P, same as the input power is same as the Q dissipated. And you already know input power is nothing but force into velocity. Simple formula. See, we get the same thing. Okay, we get the same thing. Force into velocity is Q. But anyway, I showed you using the formula like the literal way, if you do not get, so that you do not get confused. So two ways we did it. Okay, nice. Next question. Figure shows equipotential surface for two charge system at which of the labeled points when an electron have the highest potential energy. Look, electron basically means a negative charge, right? A negative charge, minus E. Now if you know potential energy U is given as K Q1 Q2 by R. Now you see, one of them, say this one is already negative. So for this U to be maximum, that means positive value we are talking about, the Q2 has to also be negative. So that means the closer the electron will be to the negative charge, the more potential energy it will have. So look at the negative Q and look at the point which is closest, B. Option B is the correct one. Let's quickly go to this next one. Atomic masses of two heavy atoms are A1 and A2. Fine. Ratio of their respective nuclear densities will be approximately. Now that's also very easy question. Those who have at least revised their class notes of the nuclear chapter, I hope all of you got it correct. The formula here lies in the liquid drop model. What is it we are talking about? Mass by volume, density. You know, mass is, let it be, each nucleon mass is small m, say. So I can write number of nucleon is A, so m into A. Now, here's what they have mentioned A with atomic number. Yeah, atomic number. Heavy atoms are, no, atomic mass, okay? Okay, atomic mass means I have taken mass numbers. Or should I? Yeah, mass numbers. Fine. Now that is how they say it mostly. That is a formalism. So m into A. Now V is the volume, and you all know radius r is given as, according to the liquid drop model, r naught a to the power 1/3. So if I go with volume, that will be 4/3 pi r cube, because nucleus is spherical. So 4/3 pi, and r cube is r naught cube first will come, then a to the power 1/3 ka cube will become a. If I put that here, so 4/3 pi r naught cube into a. Now look at it very carefully, a got cancelled out. Now everything there is in the expression is constant. Mass of a nucleon, constant. 4/3 pi, just number. R naught by definition is a constant, 1.2 femtometer. So density is actually constant of every element's nucleus available in the universe. So I'll just say 1. Let's come back to the next one. So yeah, which one is incorrect? In an isobaric process, delta P equal to 0, correct. Isochoric, delta W 0. Why? Because the W is given as P delta V. Since delta V is 0, work done is 0, correct. Isothermal process, delta T 0, correct. In isothermal process, delta Q 0, not correct. So this is the correct option for us. Simple, huh? All the simple questions. A thin circular ring of area A is perpendicular to the uniform magnetic field induction B. A small cut is made in the ring and a galvanometer is connected across the ends such that the total resistance of the circuit is R. Now when the ring suddenly squeezed at 0 area, the charge flowing through the galvanometer is. The charge flown through the galvanometer is. This question is utterly simple, I would say, guys. The only thing here is a big language of the question that is probably making you fall prey for it. Simple story is that here is an area. Okay, there is a galvanometer and stuff just to measure the current. There is no tricky thing about it. Resistance is R. Simple story. And there is some area, and suddenly after some time the area is becoming 0. Nonetheless, we all know charge flown is given as change in flux over distance R. So finally area becomes 0, therefore in final flux is 0. So I'll just say initial flux phi initial, or actually phi final minus phi initial by R. But anyway, we are talking about the value of the charge flown, which direction doesn't matter for us. So this is 0, okay, forget about it, this is 0. So the other thing will become initial flux, right? So just magnetic field B into area A divided by the resistance R. Okay, simple, just one liner. See, question took more time to read than solve. Funny one, huh? Let's come to this question. A cubical block is floating in a liquid with half of its volume immersed in the liquid. So half of the volume is immersed. So half of the height is immersed if I assume the area to be uniform. When the whole system accelerates upward with an acceleration of g by 3, that is shown here, the fraction of the volume immersed in the liquid will be x. Okay, this thing 100x equal to 1. Now here, if you think of it more physically, like this is stationary, suddenly it goes up, acceleration is there. Now these type of things are not tackled in JEE. Why? Because the very moment you see the acceleration is 0, that means it's at rest, then start accelerating, at that moment there will come some jerk. and the body will actually start oscillating. So you are not talking about that system at all, not at all. Think of a much simpler case. What is a simpler case? It is for a uniform time, it is moving with the same acceleration of g by 3 upwards. Now in that scenario, what will happen? Look, forget about this acceleration for the time's sake. The vessel is just there and the cube is just floating. At that moment, do you all agree with me? The weight of the displaced liquid, this yellow shaded part, is same as the weight of the block. So I can write mass of liquid into G will be mass of the block into G. Now if the whole system is going up with G by 3, what will happen? In the pseudo frame, if I go, only the G effective will change. That will become G plus G by 3. What will happen? So if I say that time mass of block is some m dash, mass of liquid is say m dash, some m dash, more or less amount of liquid is displaced, say. So that will become m dash into G plus G by 3, that will be mb into G plus G by 3, because you see, not only the liquid is feeling the G by 3 pseudo force, the block will also feel the same force, right? Now if you compare them, not like this, yeah, if you compare them, you see from this expressions, if you see, m dash is same as the mass of liquid. So mass of liquid displaced earlier or now is same. It is not like the blocks part inside is gonna change. Okay, if that is true, the fraction which is inside will remain the same. So the fraction inside is half, which is x is half. So 100x will be 50. Simple story. Next. So if the density of a gas at NTP is this, so density means rho, and the velocity of sound, velocity of the sound, the number of degree of freedom of the gas molecule is. Let's see how to do that. So number of degree of freedom. So basically they are asking about the F. Okay. So how to do that? Simple story is that I can write velocity of sound is gamma p by rho. Gamma p by rho with a root actually. Yep. Now if I try to simplify that, what do I get? Vs square into rho by p, that will give me gamma. And we all know gamma is nothing but 1 plus 2 by f. Now you can just simply solve this thing by putting the values here. What do we get? Let's see. Vs means 330 into 330 into 1.3 divided by this thing is 10 to the power 1.0, actually 1 atm. So 10 to the power 5 and then 1 plus 2 by f. 1.013 if you want to put here for the sake of more accuracy, you can do so. And if you check that, f will come out to be somewhat like 5.03. I hate this calculation, so I did it beforehand. So for the nearest integer, I can pick up f equal to 5. Let's proceed to the next one. The frequency of the first line in Lyman series or in the hydrogen spectrum is nu. What will be the frequency of the corresponding line? That means same line they are talking about. So first line and last line, they should have not mentioned it. Not required anyway, because the same line we are talking about. Same line means same level transition. Means first line in Lyman, if I am talking about 2 to 1, for the other case also 2 to 1 transition is taking place, but for a different element altogether. For lithium, so Z value is equals to 3. Here Z value is hydrogen, right? Here Z value is 1. Now you know this energy of the shifting, basically jumping, is directly related to the Z value. How is it? This jumping energy of the photon related to the energy of the orbits. The farther the orbit will be, the more stronger jump there will be, the more energetic the photon will be. So just directly see that. You do not need to calculate it very clearly. Energy is related as z square over n square. Am I correct? Now we are talking about n shift to be same. This thing is not going to change. The second case also same shift. So E proportional to Z square. And E is proportional to nu as well. E equal to H nu. So done. So nu dash over nu will be z case, second case is 3 square by 1 square, basically 9. So nu dash equal to 9 nu. That is the answer. Simple. Next one. 15 gram of ice at 0 degree centigrade, is added to 60 gram of water at 40 degree centigrade. Calculate the final temperature of the mixture. How to do that? Simple story is that I will make a block diagram here. 15 gram ice, 0 degree centigrade. Here we have got 60 gram water at how much? 40 degree centigrade. Now I will look at the middle portion, who is 75 gram water, or basically forget about the amount, water at 0 degree centigrade. Now for this thing to come here, what will happen? It will take heat. It will snatch heat H1. It will snatch heat H1. So I can write minus H1. And this thing to come here, it will give heat H2. It will release heat H2. So how much is H1 and H2? Let us calculate that first of all. So H1 is going to be, so just temperature is same, so only phase transition happening, so ml. So 15 into latent heat is how much? 336. Yeah, that is the stuff. And the other one, H2, is how much? Let's see. So temperature change is happening here, no phase change. So MST, 60, S is 4.2, here the specific heat, and change in temperature is how much? 40. Correct. Now first let us find out H2 minus H1 to see what happens in these two processes, whether do we get an excess energy or do we have a lack of energy. If the lack of energy is there, then what will happen? The entire thing will come at the 0 degree centigrade, but some of that will still stay ice and some of them will become liquid. However, if the H2 minus H1 is some positive number, that means we still have some energy left even after achieving all the stuff at water at 0 degree centigrade. That means with the extra heat, we will heat up the water now. Let us calculate these things. So delta H is equals to H2 minus H1, that is equals to 40 into 60 into 4.2 minus 15 into 336. I can calculate this, but I don't want to use my head. But okay, I think I am not fortunate enough to bring my mobile. Okay, let me calculate that. Or rather, I can use the Windows calculator, can't I? 40, 60, 4.2. 40 into 60 into 4.2. That is how much? 10080. If I subtract that with 1536 minus bracket, is there? No, minus 15 into, no, that thing doesn't work. So let me add plus 15 to come back my result. 10080. 15336, huh? Now let me come back. 15 into 336. We get 5040. 5040. So is the difference in 5040? If I'm not too wrong, answer is 5040 here. Now, if I look at it, using this temperature, the entire water will heat up. So simple story, just write entire water is 75 gram, specific heat as 4.2, and temperature will become T, that is equals to 5040. So 5040 by 75 by 4.2. Again, man, I'm going to use calculator. 5040 by 75 by 4.2. Okay, I get 16. So that is the correct answer. Okay, so T is equal to 16 degrees centigrade. You will have to do using your own brain in the examination hall, but yeah, I am using calculator here because it's the end of the day and my mind is kind of exhausted. Let's come back to this question. A uniform heavy chain is placed on a table with part of it hanging over the edge. It just begins to slide when hanging part is 1/3 of its length. The coefficient of friction between the table and the chain is mu. Let's see this really quick. So this is the chain. They say 2/3 is hanging, right? And 1/3 is 1/3 is hanging and 2/3 is lying on the top. So I can just say, no, this mass is, since if I assume the homogeneous ring, that is the mass distribution is very much homogeneous, so I can say this thing is 2/3 m mass of this thing, and the mass of this thing is 1/3 of m, right? Now this hanging part, this part is pulling the other stuff down with how much force? 1/3 mg. Do you all agree with me? Right? And here along this surface, if I assume that there is a mu, what will happen? There will be some normal relation here, some normal relation here. That will be same as 2/3 of mg, basically the weight, right? So mu into n, so frictional force here will be 2/3 mu mg. That will balance the force of pulling by the hanging part, that is 1/3 mg. Now do the calculation really quick. 3 mg, 3 mg. So I get mu is half. So 2 mu is equals to 1. So answer is 1. Got this? Next. Okay, that's all we had. Thank you everyone for tuning up to here, and I hope you all learned a lot of things here. Please let me know if you have any other suggestion from your side, and if you did understand or not, let me know that as well. I will follow whatever you feel, and obviously we'll apply the same suggestion, or if you think it is okay, so I will try to keep it like the same way. I will not do any modification, and meet you the next day. Bye bye.